Hello everyone, welcome to Wings of Physics. Myself Deepali Kulkarni from PVP Junior College, Pravaranagar, Loni. We will continue our topic Thermodynamics and today's lecture is lecture number 6. In this chapter, we will study the thermodynamic process. What is quasi-static process? What is the path and work done during a thermodynamic process? That is nothing but we have to prove that the work done is a path function. Okay, now let us start. Consider a thermodynamic system. This is a thermodynamic system. In that system, ideal gas is there and that system is fitted with movable, massless and frictionless piston. Pi is the initial pressure of this system and Vi is the initial volume of this system. We have to change the initial state of the system to final state. Means final pressure is P up and final volume of the system is V up. And we have to change the initial state to final state. Then what is the definition of thermodynamic process? Thermodynamic process is a procedure with the help of which we can change the initial state of the system to final state of the system. Understood? During that change, the heat absorbed by the system, sometimes heat leaves through the system. When heat absorbed by the system, it considered as a positive. When it leaves through the system, it considered as negative. Sometimes work done by the gas means expansion is there. Work done by the gas. Work done is positive work done. When compression is there, work done on the gas. Negative work done is there. And during that change, the changes in system, they occurs very slowly so that thermodynamic equilibrium of that system that should maintain. What is thermodynamic equilibrium? When the system simultaneously satisfy mechanical equilibrium, chemical equilibrium and thermal equilibrium. At that time, we can say that our system is in thermodynamic equilibrium. And to maintain this thermodynamic equilibrium, the changes in the system, they occurs very slowly. And that system is called as a quasi-static system. Understood? When changes in the system occurs very slowly or infinitesimally slowly, so that thermodynamic equilibrium of the system that should maintain, that system is called as quasi-static system. Understood? Then we have to study about the path. What is the path? Suppose consider a point A. In that PV diagram, point A is having coordinates Vi, Pi, means this is the initial state and we have to change the system final state, means final state is at point B. Coordinates of point B are V up, P up, means we have to change a thermodynamic system from initial state to final state. We can change that initial state to final state with three different paths. Means this is the path first, this is the path second and this is the path third. Okay. And what is the definition of path? When a thermodynamic system changes from initial state to final state, it passes through a series of intermediate state. It passes through a series of intermediate states, and when these intermediate states plotted on a PV diagram, this intermediate state plotted on a PV diagram, that is called as a path. This is path first, this is path second and this is path third, and we have to calculate what is the work done during the path first, what is the work done during path second and what is the work done during path third. Then consider figure B, means path first. initial state of this system, that is the VI-PI, and final state, that is VF-PF. Okay. What happened during that change? During that change, volume goes on increasing. Means Vi is initial volume, Vf is the final volume. Volume goes on increasing, means expansion is there. When expansion is there, positive work done is always there. Volume goes on increasing, pressure goes on decreasing. Pi to Pf, that pressure goes on decreasing. Volume goes on increasing, pressure goes on decreasing, and area under the curve means the shaded area in this PV diagram, that gives you the value of work done, and that is the positive work done. Means during the path first, volume goes on increasing, pressure goes on decreasing, and area under this curve, that is the positive work done by that system. Then consider path second. During the path second, first system goes from A to C, and after that system goes from C to B. Okay. Then consider the figure C. During the path A to C, what happened? This arrow indicates that volume goes on increasing, but pressure remains constant. Pi is the pressure, that remains constant. Means during the change A to C, volume goes on increasing, expansion is there. When expansion is there, positive work done is there, though pressure remains constant. We already studied that case in earlier lecture. Then during the path CB, what happened? Line is parallel. This CB line is parallel to y-axis, and therefore volume remains constant. Change in volume, that is equal to 0. Work done is 0. Means during this CB path, there is no work done, and therefore the shaded area under this curve, that gives you the positive work done. Though during the path CB, no work done is there, but shaded area gives you the positive work done. Means during the path second, this is the amount of positive work done. Understood? Then consider third path. During the path A to D, line is parallel to y-axis. Again, volume remains constant. Change in volume, that is 0, and therefore work done is 0. Means during path AD, work done is 0. But what happened during path DB? See this arrow? Volume goes on increasing. Pressure remains constant. Pf is the pressure. That pressure remains constant. But volume goes on increasing. Means the shaded area, that gives you the positive work done. Means in all these three cases, initial value and final value of the system, that is constant, but work done in three different cases, that is different. Means we can prove that the work done, that depends on the path. If path goes on changing, work done goes on changing. Understood? And this indicates that the work done is a path function. I already told you, heat and work, they are the path function, and change in internal energy, that is a state function. And in this manner, we can prove that the work done is a path function. Understood? Question may ask on this topic. Prove that a work done is a path function. We can prove in this manner the work done is a path function. I hope all of you understood this topic. Okay? Please like, share and subscribe my channel. Okay, thank you.